In the section 2, we will be discussing about Ethereum's token standards, which is the ERC20 standards. What are ERC223 standards? We will create our own custom token on Ethereum and we will deploy it. Today in this video, we will be learning about token generation. We will be discussing how to create a token smart contract using Solidity, how to write it in cost-efficient manner like using inline assembly language of Solidity, and more. First of all, we will directly dive into the code. Everyone hates to learn theoretically, right? So let's dive into the code first, and then let's discuss about inline assembly language, how to write it more efficient manner. Firstly, like I said, you always have to start your contract with defining the version of the Solidity. Now, before getting into our token contract, let me discuss about the interfaces we are going to use, the functions which we will be using. Briefly, this is an interface of ERC20. We have a function for transfer from, we have a function to approve, and we have a function for allowance, and there is an event for approval. Event is just to make sure that it's going on correctly. It's for ourselves, for our own purpose. We have ERC223 contract. Well, this is not a contract, this is to an interface. This interface has a function which is a transfer function and a transfer event. Another file which we are going to use is ERC223 receiving contract. This has one basic function which is important, the fallback function. Now let's hop on to our own code. To put it simply, we will be using these all three files. We will import all the three files and then we'll write our own contract. Our contract mainly has the name of our contract, the symbol, the decimal, and the total value supply. This has to be in the constructor. Firstly, we can import here. Since we have all the files in our browser itself, you don't have to specifically select the path from somewhere else. Here are three functions. Well, not three functions exactly. The first one is a constructor. Let me give you a short note about this. In the previous versions of Solidity, constructor is created by using the keyword function followed by the contract name itself. But in the latest versions of Solidity, we don't do that anymore. We directly use the keyword constructor, then followed by public or private. If you have any arguments, you can give it into the brackets. There are two functions which we created in this contract. One is the total supply, which returns the total supply. Another one is balance of, which returns the balance of a specific address. For those who don't know how to create a function in Solidity, let me explain you in a simple way. You use the keyword function followed by the function name. In the bracket, if there are any arguments you're passing to the function, you give that to them. Then followed by public or private or any other access modifier, a custom access modifier, followed by the returns if you're returning something. For example, here it is uint, you give that as a parameter in the returns bracket. Then the body of the function itself. Now, apart from these two main functions, which merely return the value of total supply and balance of an address, there are other functions which we take from the interfaces which I explained you before, the ERC20, 223 and ERC223 receiving contract. The function transfer takes the input, the address to which we are sending the value, and the value itself. The return will be a boolean value. Well, a boolean value, if it's a true, that means your transfer has been successfully sent. If it's a false, then it didn't. Inside the function is a basic mathematical calculation. Now this is important because while creating a contract, you must make sure once or thrice, if not 10 times, that this is correct. The balance you're trying to transfer should deduct from your balance and it should be incremented into that address balance exactly. Slight miscalculation will create a huge chaos. The function isContract is nothing but it takes the input address and returns the boolean value. Now the use of this function is to know that if a specific address is having a contract or not. Well, how do you know that? That's a smart question to ask. You can simply search or get the written value of the code size on that specific address. If there isn't any contract on that address, that means there isn't any code. That means the code size will be obviously 0. By any chance, if the code size returns greater than 0, that means a contract is present. This makes sure that you're not sending value to a address which has a contract. Here is another transfer from function. A transfer from function has 3 input parameters. One is the from address from which you're transferring the value, the to address to which you're transferring the amount, and the amount itself. Like other transfer functions, this has the same returns, which is boolean. Inside the body of this function has the same mathematical calculation, which you need to make sure. The bottom two functions are just for allowance and an approval. Simply put, this is how to create a smart contract for token generation. The key points to take here is you need to mainly mention the token name, token symbol, the decimal, which will be generally 18, and the total supply in the constructor. Apart from these, other functions are merely your choice. Well, don't take that completely because some functions are mandatory, and these functions you can find it in the Ethereum's website. On the Ethereum, you can find the standard token functionalities. To create an ERC20 token, you need to actually have all the functions which is specified on this ethereum.org website. Lastly, I would like to discuss about the inline assembly language I was talking about. The reason why I'm mentioning this is this reduces the cost of a transfer function or any other functions dramatically. Well, not always, but if you are using for loop or if else clause in a function body, then there are pretty good chances that you can decrease the gas cost of that function. How do you do that? Pros and cons of inline assembly, first of all, is inline assembly language is a low-level language to interact with. That means it's hard to understand and get it through your head. It can be used to provide cost-efficient functions sometimes. And although it is cost-efficient at times, we generally won't use it as it is hard to understand, like I said. At the same time, sometimes it can be less cost-efficient too. Now remember, all this blockchain field is continuously being updated, so things which are correct in the past couple of weeks might be wrong. Thus, you need to bear this in mind that as of now, I believe that inline assembly language can reduce the gas cost in particular circumstances only. I will be explaining about how to create a contract using inline assembly language later on in the coming videos. In the next video, I will be discussing about deploying our token